Welcome back to Physics with Drishti. Today we will learn B.Tech Engineering Physics important question. And our today's questions carries 6 marks. Each question carries 6 marks, 6 marks important question. And in this video we will cover the topic, our second unit, that name is modern physics. So let's start. Our first important question is derive the expression for time dependent Schrodinger equation. See, in this unit there are two important question, one which is time dependent and another which is time independent. So let's start with the time dependent Schrodinger equation. So for time dependent Schrodinger equation, just start with the case 1 for a free particle. Free particle, that means what? Everybody know the total energy which is kinetic energy plus potential energy. Okay, so there is no potential, only kinetic energy. That means the particle is free. So let's consider, first of all, start with the wave function, the free particle moving along its x-axis, and we can just assume, okay, psi of xt, which is a into e to the power I kx minus omega t. This is our function, where omega is what? 2 pi nu angular frequency, and k is what? K is your wave vector, that means 2 pi by lambda. So see, this is our concept which is useful here. The total energy of free particle is kinetic plus potential, but potential energy is zero because the particle is free. So only E is equal to what? E is equal to p square divided by 2m. This is our equation number 2. Now according to quantum theory, you have to write energy is what? So we already know E is equal to h nu, but every time just multiply 2 pi and divided by 2 pi. H by 2 pi, that means what? H cut, and 2 pi nu is equal to what? Omega. So you can write E is equal to h cut omega, and similarly P is equal to h cut k. So always remember these two equations, which are very helpful for the another steps. So now always go with this equation number 1 and take the differentiation and just equivalent both condition. Go with t and x. So let's start with the t. Differentiate your equation number 1 with respect to t. So you know what is the coefficient of t? Omega I n minus. So I omega and negative sign is multiplied with the function. So whenever we are taking psi differentiation with respect to t, we got minus I omega psi of xt. Got the idea? Now just multiply both side I h cut and I h cut. So what happened? I square is minus 1, only remaining term is h cut omega, and everyone know E is equal to what? H cut omega. So just replace E. So this is our equation number 5. Remember this. Now take the differentiation of the equation number 1 with respect to t, but twice. So just take the differentiation. What is the coefficient of x? K and I. So both time k and I, that means I k square is coefficient of the function, and I square is minus 1. So minus k square psi. This is our output. Now just multiply both side, h cut square divided by 2m. So this is left hand side, this is right hand side. You know, now h cut and k, that means what? H cut and k, that means p is equal to, whenever we h cut k. Okay, so just replace h cut k is equal to p. So h cut square k square, that means p square. So we got equation number 6. And now p square by 2m, that means what? E. Remember na, E is equal to p square divided by 2m. So we have a equation number 7. Now just remember equation number 5. Equation number 5 is right hand side E psi, and again equation number 7 right hand side is E psi. So just comparing equation number 5 and equation number 7, we got this. This is this side, and this is the side of equation number 5. Got the idea? So this is your one dimension equation, time dependent Schrodinger equation for a free particle. But whenever potential is included, what happened? Let's see. This is your second case, particle under an external force. That means E is equal to kinetic energy plus potential energy, but here some potential, that value is V of xt, which is depends on x and t both. Okay, so now let's go with the same equation, just multiply psi of xt both side. So what we have, e psi of xt, p square psi of xt, and this is, got the idea? And now what you have to do, just put the value p square by 2m psi, that left hand side equation number 7, put the value. So we got this. Now e value is what, I h got del psi by del t, put the value of e psi. I am talking about equation number 5 and equation number 7. Directly put the value of e psi from 5, this value from 7. So we got this equation, and now in this equation psi and this psi is common, so you can write like this. This is your last equation, one dimensional time dependent Schrodinger wave equation. So whenever they are asking to derive the time dependent Schrodinger equation, this is your answer. Up to this, remember h cut square divided by 2m del square by del x square plus v of xt psi of xt is equal to I h cut del psi by del t. This is your equation. Got the idea? But now whenever they are asking derive the time independent, so up to this your process is same. But in this equation, now check, this is t, okay, and again this is t, and again this is t. Now we have to remove the time, then the equation becomes time independent. So let's see. Our second important question is derive the expression for time independent. So this is your time dependent equation. Just try to remove this t. Got the idea? So for that, just consider whatever your potential is only depends on x, not t. Okay. Now just consider whatever your wave function psi of xt, which is not a same function, we can write psi of x and f of t. There is another different function which is depends on t, and try to remove this f of t. Got the idea? So what is our idea? Just replace whatever v of xt with replace with v of x, and whenever we have a psi of xt, just replace psi of x and f of t. So can we write psi of x and f of t here, and again psi of x and f of t here? Got the idea? Now multiply it. So you got the idea? Okay, h cut square divided by 2m del square by del x square. So only this term is depends on x. So f of t is a as a constant, and again a v of x, psi of x, f of t, and again multiply with this. So this is the derivation with respect to t. So this terminology is here, and psi of x is constant. So that's why it's here. Got the idea? So this is our different equation, and you can see every time we are dealing with del, but you can write here d also, because जो दो चीजें थी, एक x था और t था, अब वो दोनों हमने डिफरेंट लिख दिए हैं. So whatever this equation, just divided by psi of x and f of t. How it look like? Just divided by psi of x and f of t here, again psi of x and f of t, and again psi of x and f of t. See here, psi of x, f of t, psi of x, f of t cancel out, only v of x is here. F of t cancel out. What happen? Only psi of x here, and here psi of x cancel out. Here f of t. Now just compare with this equation. In my left hand side, only depends on x, and in my right hand side, only depends on t time. So can we write this is equal to this is equal to as a constant, and that constant value is what? That constant value is, this is your left hand side, this is your right hand side, which is equal to the constant e. Okay, so can we write left hand side is equal to a particular constant? Yes, we can write, and just multiply these things to here. So what we get? We get this. Got the idea? So this is your, now check, left hand side there is no t, so it is not depends on t. So whatever our last form, h cut square divided by 2m d square by dx square plus v of x I of x is equal to e psi of x. This is your time independent Schrodinger wave equation. Got the idea? So this video is only for revision purpose, but how to derive it, this is the methodology. Okay, now next question. Another important question. Write the expression of energy for a particle trapped in one-dimensional potential box. That means our important question, particle in one-dimensional box. Another question, write the expression for wave function. See, sometimes they will ask only for energy. So derived up to energy equation. And sometimes they will ask derive the wave function, so up to psi. And direct question, particle in one dimensional box. So these three questions are similar. And how to solve it? Let's start with our first case. This is our case. This is our one dimensional potential well, our particle that mass of, you can write free particle mass m is placed in a one dimensional box. That potential is infinite and that's width is 0 to a. Now you already know inside this box the particle is free, but the particle has not sufficient energy to cross this barrier and going to outside the direction. Okay, so this is our ideology for this particular thing. Particle is free, the potential energy V of the particle inside the box is 0. Inside the box V is 0, but outside it is infinite. So can we write potential energy particle outside the wall is infinite. So can we write V is equal to 0 when the particle is inside, but V is equal to infinite when the particle is outside. So this is our two cases. And now try to solve this case. For take the solution with the using of Schrodinger equation. Now tell me which equation is helpful, time dependent or time independent. See, every time particle is inside the box, that means it is not depends on t. So use time independent Schrodinger equation. So use the Schrodinger one dimensional time independent wave equation. This is your time independent wave equation. Here the probability psi square is 0 outside the box because particle is always inside the box. Okay, now try to solve this. See, our particle is free, that means V value is 0. So put the 0, only remaining thing is this. Okay, and now assume it 2me by h cut square is equal to k square. Just for a constant, 2me by h cut square is equal to k square. Always remember this thing. This is for assumption. Try to simplify it. So our equations becomes this. This is look like a second order differential equation and we already know how to solve it. That ideal solution is available. A sin kx is equal to b cos kx. So use our equation number 5. And now try to identify a, b and k because these are the unknown quantity. So calculate it using the boundary condition. Remember boundary condition, our width is 0 to a. So when the particle is at a 0 or at a, your wave function become 0. So x is equal to 0, psi 0, x is equal to a psi 0. So use the first boundary condition. This is our function. Okay. Now try to put the value x is equal to 0. So psi is 0, x is 0 and this is 0. Sin 0 value 0. This value is also 0. Cos 0 1. So remember is b. So what we get? B is equal to 0. This is your equation number 6. Now use the second one, x is equal to a. So put the value of x is equal to a, psi is 0 and again this is a. Okay. Now we already know b is equal to 0. So only remember thing is what? A sin k is equal to 0. Now always a is not equal to 0, otherwise phi is always 0. So sin k is equal to 0 and when psi becomes 0, that value is equivalent to n pi. So you can write down k is equal to n pi by a. Now remember what we assume, k is equal to 2 pi m by something. Okay, so now equivalent k square we heard na? Yeah, k is equal to 2me divided by h cut square is equal to k square. So this is your assumption and what we get, k value is n pi by a square. So just square it. So this is the substituting equation 7 in equation number 3. And now find the e. So just multiply h cut square and divide it by 2 pi. So what we get? We get this. Remove this h cut is equal to h by 2 pi. This is your energy equation. If they will ask up to energy, this is your last equation. And where n is 1, 2, 3 or whatever things. But if they are asking, try to find out the wave function. So only remember thing is psi is equal to a sine kx, because b value is always 0. Okay, now try to find out a, because k is equal to what? N pi by a. X is similar, only a value is we don't know, so try to find out the a value. For that we have to go with the probability p, that means psi square integration is always 1, because particle is always inside the box. Now put the value of psi, a square sine square n pi x by a is equal to 1. Sine square a square is going to this side, and sine square integration is not possible, so we already know 2 sine square theta is equal to 1 minus cos square theta. So just use this sine square theta is equal to 1 minus cos square theta divided by 2. So this is using this trigonometry equation. And now what we get, this 2 is multiplied with this side, and just try to simplify it and take the integration. Only remember thing is what? Only remember thing is a, and find this a value. So a value you got in root 2 by a. Now put this a value in our psi equation. This is our a value. So just put root 2 by a. So this is your psi equation. So if they are asking, try to find out the wave function in particle in one dimensional box. So up to this, it is your answer. So you got 6 out of 6 marks. Got the idea? Simple, very simple. Next important question is, define the quantum tunneling with the example. Some examples are needed. So first of all, very basic thing, quantum tunneling, that means what? See, suppose we are supposing this is the barrier and this particle is not have a sufficient energy to cross this barrier. But what happened? Classically, it is not possible. But quantumly, if the particle has not sufficient energy to cross the barrier, but sometimes what, the particle will behave as a wave, and particle can penetrate throughout the particular potential or the this particular things, and some wave function is possible outside this particular infinite potential or whatever potential barrier we have. दैट मीन्स व्हाट, हम सिंप्लीफाई उसको कर दे तो इस पार्टिकल की उतनी एनर्जी नहीं है वो क्रॉस कर पाए, लेकिन कभी कभार वो इस दीवार को पेनिट्रेट कर जाता है, जो भी पोटेंशियल है उसको पेनिट्रेट कर जाता है और दूसरी तरफ भी आ जाता है। ऐसा क्लासिकली पॉसिबल नहीं है, लेकिन क्वांटम मैकेनिक्स में ये बातें हैं, इसी बात को बोला जाता है क्वांटम टनलिंग। सो लेट्स ट्राई टू सिंप्लीफाई इट। Quantum tunneling is a fundamental concept in quantum mechanics, describing the ability of particle penetrate energy barriers that classical physics would deem im- impenetrable. Okay, in classical physics, particle barrier with energy higher than on its kinetic energy are unable to pass through it. That means in the classical mechanics, suppose the barrier height is this and this kinetic energy is not sufficient to cross this. It is not possible to cross this particular barrier. But in quantum level, the particle exhibit both particle as well as wave, and this wave particle duality enabled them to exhibit the tunneling. यही जवाबदार है wave particle duality. So the quantum physics particle are described by wave and a particle both has per de Broglie wavelength. So let's see what is the quantum tunneling. When the particle of sufficient less mass on the barrier of the infinite potential, the solution of Schrodinger equation is exits other side of the barrier if energy of particle is less than the barrier height. These phenomena are the small probability that particular particle may be present outside the barrier or other side of the barrier. This phenomenon known as a quantum tunneling. So in the category of quantum tunneling, they are writing other side the solution of Schrodinger equation is possible. So why it is possible? Because the phenomena is the particle can going through the tunnel, and that's why the particle probability is possible other side of this particular potential thing. And now write down the simplified. However, the probability exponentially decrease as the height or width of the barrier increases of mass the particle increases. Very simple. And here one of two electrons, one or two examples are here. Electrons can tunnel through the barrier of thickness 1 to 3 nanometer, where proton can tunnel through the barrier of thickness 0.1 nanometer. See, and some another example we have tunneling play an important role in which nuclear fission, in star, radioactivity, tunnel diode, scanning tunneling microscopy, inner electron tunneling in photosynthesis, proton tunneling in DNA mutation. So these are the example of the quantum tunneling. Got the idea? And here one another example is given. Whatever this wave had not sufficient energy to cross the barrier, so some waves are transmitted and some are reflected using this condition. So you can write this also. So just explain. You got 6 out of 6 marks in this particular question. Next question. Very important question. State the de Broglie hypothesis. First of all, write down the hypothesis and then derive the expression. Very simple. What is the de Broglie hypothesis? We already know. De Broglie proposed that matter proposed as particle, wave as well as particle, both characteristics. And he suggested that moving particle is associated with wave that called de Broglie wave or matter wave. So he supposed as well as wave or particle, and every particle associated with a wave, and that name is de Broglie wave. So can we write the wavelength lambda is equal to h by p, and if it is a particle, so it has a mass, so can we write h by mv. So this is the de Broglie equation, and lambda is de Broglie wavelength. Now try to derive this equation. Okay, so let's start with the wave particle duality. We already know this is our first equation, E is equal to h nu. Now go with the relativistic particle equation. Total energy can we write E square is equal to p square c square plus m0 square c raised to 4. But for light there is no mass of light, so this rest mass m0 becomes 0, so only become E square is equal to p square c square. Now remove the square, only remember E is equal to pc. This is your second equation, this is your first equation, this is your second equation. Equivalent, both E is equal to pc is equal to h nu. So can we write pc is equal to h nu? And now try to find out the value of p. So p is equal to h nu by c. Nu by c is equal to c by can we write nu by c? So nu by c is equal to 1 by lambda. So just remove it and try to write down 1 by lambda. So p is equal to h by lambda. So can we write lambda is equal to h by p, and p is equal to mb. So your equation is derived. Very easy equation. Easy question. 6 out of 6 marks you get whenever these questions are asked, or these question is asked in your not asked, these question will ask in your examinations. So all the best to all of you for this question also, because it is a very important question regarding 6 marks. Next, last question. What is the wave function, and state the significance of the wave function. So first of all, define the wave function. What is the wave function? So I will start from directly here. Just read these sentences. In the matter wave, quantity that varies is called the wave function, denoted as a psi. This is the some description. What is the wave function? So the space-time behavior of each moving quantum mechanical particle can be described by a function, that function known as a wave function. So suppose generally we are denoted as a psi and x and t. So x, which is denoted as a space, and t, which is denoted as a time. So every time it is denoted as a space and time of a moving quantum mechanical particle. Okay, and this gives the idea of probability of finding the particle about the given position. How? Suppose this is the wave function. Always figure is very important, and whenever magnitude of this function is large region, where the probability of finding the particle is high. That means here the probability to find the particle is very high. And when the magnitude is small, so the probability is less. That means comparable to here, the probability is very less to find the particle. Got the idea? So psi of RT gives the complex knowledge of behavior of the particle. Psi of R, the stationary state which is independent of the time. Can we write psi of R? That means what? It is independent with the time also. Got the idea? So this is all about the wave function. Just draw the figure and explain it, how it uh, wave function works, or what is psi of R and T, that R represents space and T represent time. Draw this figure and explain all these things. When the magnitude is large, the probability is finding the particle is high. If it is small, then the probability is low. And at the end, what do we have to write? State the significance. So write down 5 significance of the wave function. These are the significance of the wave function, well behaved function. So your first answer is psi of RT gives the idea of the probability of finding the particle about a position. Second, psi of RT, their first derivatives must be continuous and single value everywhere. Your third significance, that means only a one value is possible at a particular space and time. Psi of must be normalized. That means what? That means when psi must go to 0, as x is equal to infinite, y is equal to infinite, and z is equal to infinite. And the integration of psi square must be finite over all a space. You already know integration of psi square is equal to 1. So this is your third point. Your fourth point, the magnitude of psi of RT is large in region where the probability of finding the particle is high. This is the same thing. And whenever the magnitude is small, the finding particle probability is very low. And the last but not the least, the product of the normalized wave function psi and complex conjugate psi star gives the probability of finding the particle per unit volume in a given space a particular time. That means integration psi and psi star, that means integration of psi square is equal to 1. That gives probability of finding the particular per unit volume in given a space at a particular time. So just write down these 5 significance of the wave function, then you got 6 out of 6 marks. Very simple question. First of all, explain the wave function and then write down the significance of the wave function. I hope you got the idea. And now these 5 questions are very important for the unit modern physics or quantum mechanics. Thank you very much to all to give us support our channel Physics Ki Drishti, and in the next video I will provide rest of the 3 units important questions. So I think laser and quantum mechanics both are a very important unit for us for our end semester examinations. So all the best to all of you. All the best to all of you, and thank you very much to all. Thank you very much.